This episode, I'm joined by Marc Andreessen to discuss accelerationism, AI, technology, the future, energy, and more. I'd like to say a big thank you to all my paying patrons and subscribers for making all of this work possible. And if you'd like to support the podcast as it runs off patronage alone, then please find links in the description below. Otherwise, please enjoy. So, Marc Andreessen, thanks very much for joining us on Hermitix podcast.
Hey, James. Thanks for having me.
We are going to be discussing accelerationism, AI, technology, the future. Technology is probably the key one here, I think. But I want to basically begin with probably something that on the usual podcasts you go on, you probably aren't asked. Like, a lot of people know who you are, but in the sphere that I'm working, people might not. So, just tell us a little bit about yourself, what it is you do, before we get started here.
Yeah, so I'm probably the polar opposite from your usual guest.
Exactly.
So I'm bringing diversity to your production. So I'm an engineer. So by background, I'm an engineer. So I'm a computer programmer, computer science, computer engineer by background. I was trained in kind of the old school of computer science, where they kind of teach you every layer of the system, including hardware and software. And then I was a programmer and then an entrepreneur in the 90s. And probably my main kind of claim to fame is I was sort of present at the creation of what today you'd consider the internet, sort of the modern consumer internet that people use. And so my work, first at the University of Illinois and then later at a company I co-founded called Netscape, sort of popularized the idea of ordinary people being online. And then help to build what today you experience as the modern web browser and kind of the modern internet experience. And then I was involved, through a broad range of Silicon Valley, kind of waves over the course of the next 20 years in the 90s and 2000s, including, cloud computing, where I started a company in, and social networking, I started a company in. And then in 2009, I started with my longtime business partner. I started a venture capital firm, and our firm, which is called Andreessen Horowitz, is now kind of one of the firms at the center of funding, all of the new generations of technology startups. And maybe the main thing I kind of underline there is just technology, quote unquote technology, high tech computer technology in particular. Kind of used to be, it's always been kind of interesting and important in the economy for the last 50 years or something. In the last 15 years, technology has, I think a lot of people kind of feel that like technology has really spread out and it has become, integral to many more aspects of life. And so my firm today finds itself very involved in the application of technology to, everything from education, housing, energy, national defense, national security, as well as kind of every, possible, artificial intelligence, robotics, kind of every different dimension of how you might touch technology in your life.
Mm-hmm. Mm-hmm. And it's you picked up on something that will come into the conversation in a couple of questions' time. But this notion of you is basically completely opposite to the majority of guests, not in a bad way, but often it's a lot of philosophy and which theory and not practice, and also this notion of technology in relation to either pessimism or optimism. And this is super key, I think, for the ongoing atmosphere of really the West, of where we're going to end up. But before we get to these questions, I mean, this is a question I'm slowly phasing out, but I think it will work for the sake of our conversation because we're talking more broadly around themes. I know you've listened to the podcast before, so it is the Hermitix question. You can place 3 thinkers, living or dead, into a room and listen in on the conversation. Who do you pick?
Yeah, I think that maybe I'll give you 2 versions of the answer, and then maybe I could combine them. So there's kind of the timeless answer, and the timeless answer would be something like Plato or Socrates, and then Nietzsche. And then maybe I'd throw in, one of your, one of your favorite people, Nick Land. I think would be interesting. The somewhat more applied version of that would be something a lot. This is sort of maybe a little bit more topical these days with this movie Oppenheimer that just came out. But it's like John von Neumann, who was one of the co-inventors of both the atomic bomb and the computer. Alan Turing, who became famous a few years ago with another movie, The Imitation Game, and then let's throw in Oppenheimer there also, because those three guys were sort of, present at the creation of what we would consider to be the modern technological world, including literally those guys were at the center, especially von Neumann and Turing were at the center of both, World War II, the atomic bomb, the sort of information warfare, the whole, kind of decryption, kind of phenomenon, which really, a lot of people think won World War II, along with, along ultimately with the A-bomb. And then also right precisely at that time with those people, the birth of the computer and everything that followed.
Mm-hmm. So is that more of a practical room for you, or in terms of like a vision going forward into the future, or is there something else going on there between those sort of six figures?
Those guys were it's almost impossible to overstate how smart and visionary and far seeing they were. Like, there's actually the von Neumann biography came out recently called The Man from the Future. And if anything, like von Neumann is a more interesting character than Oppenheimer in a lot of ways, because he touched a lot more of these fields. And of the people who knew them, that, von Neumann was always considered that he was the smartest of what were called the Martians at that time, right? Which were the sort of group of super geniuses that originated in Hungary, in that era. And so, look, they were very, very conceptual thinkers. I'll just give you one example of how conceptual they were, how profoundly smart they were. So they basically birthed the idea of artificial intelligence right in the middle of the heat of World War II. Like the minute they created the computer, right? They created like the electronic computer as we know it today in the heat of World War II. And then they immediately said, aha, this means we can build electronic brains. And then they immediately began theorizing and developing designs for artificial intelligence. And in fact, the core algorithm of artificial intelligence is this idea of neural networks, right? Which is this idea of a computer architecture that sort of mirrors in some ways the sort of mechanical operation of the human brain. That was literally an idea from that era in the early 1940s. There was a paper, two other guys who were in this world wrote a paper in 1943 outlining the theory of neural networks, and that literally is the same technology. That is the core idea behind like what you see when you use ChatGPT today, 80 years later. And so there was a very, very deep level of intellectual and philosophical. I don't know what it is. Like they tapped into or discovered or developed a very deep well that we're still drawing out of today.
I was gonna ask that immediately, but you covered it. I mean, is there any significant changes between AI then and AI now, or is it really just a matter of practicality? Like we've got more resources and more ability to create it.
Yeah, we're at this fairly shocking moment. So for people who have been following this, basically it's one of these amazing things where it's like there's like this 80-year overnight success that all of a sudden is paying off, and so that there were 80 years of scholars and researchers and projects and attempts to build electronic brains, and like every step of the way, people thought that they were super close. There was this famous seminar on the campus of, I think it was Dartmouth University in like 1956, where they got this grant to spend 10 weeks together. They'd get all the AI scientists together in 1956 because they thought that after that they'd have AI, and and it turned out they didn't. And so it's one, but like it's starting to work, right? And so when you use ChatGPT today, or you use on the artistic side, you use something like Midjourney or Stable Diffusion, like you're seeing the payoff from that. I think the way to think about it is it's the deep thinking that took place up front. And then just obviously a tremendous amount of scientific and technological thinking and development, and elaboration that took place since then. But then there's two other kind of key things that are making AI work today that are kind of there's sort of a combination of sort of incremental but also step function breakthroughs along the way. So one is data. And so just like it turns out a big part of getting a neural network to work is feeding it enough data. And so, and the analogy is irresistible, right? It's like, if you're trying to educate a student, right, you want to feed them, a lot of material. In the human world also, and so it just turns out there's this thing with neural networks and data where, as they say, quantity has a quality all its own. And you really needed actually the internet to get to the scale of data. You needed internet scale data. You needed the web to generate enough text data. You needed Google Images and YouTube to generate enough video and imagery to be able to train. So we're kind of getting a payoff from the internet itself, combined with the neural networks. And then the third is the advances in semiconductors. And and this is sort of the famous Moore's law, but it's this phenomenon that that kind of we refer to as quote unquote teaching sand to think. And so kind of this idea, right, that you can literally convert silicon, sand, rocks, into into chips and then ultimately into brains. Is kind of this amazing thing. And actually, as I don't know if you follow this stuff, but as we're recording right now, there's this like amazing phenomenon happening in the world of semiconductors and physics right now, which is there's this we may be right now, we may have just discovered the first room temperature superconductor.
I've been seeing this, but I'm not smart enough. Can you give me a brief overview of why this is so important? I mean, I'm guessing, is this a resource input issue?
So basically, every time you build a circuit today, right? Every time you build any kind of circuit, a wire, a chip, anything like that, an engine, a motor, you have basically this process. And by the way, this actually relates to the philosophy of accelerationism that we'll talk about. But you have this sort of thermodynamic process where you're taking in energy on the one side, right? And then you have a system, right? Like an electrical transmission line or a computer chip or something. You have a system that's basically using that energy to accomplish something. And then that system is inefficient, and that system is dumping heat out the other end. And this is why when you use your computer, if you got an older laptop computer, the fan turns on at a certain point. If you have a newer laptop computer, it just starts to get hot. You probably notice your phone starts to get hot. Batteries every once in a while do what they call the cook-off. They lithium-ion batteries will explode, right? Like you're dumping. There's always there's always a byproduct of heat, and therefore sort of increased entropy kind of coming out the other side of any sort of electrical or mechanical system. And that's just because with kind of running energy through wires of any kind, you just have a level of inefficiency. By the way, the human body does the same thing, right? Like we take in energy, and then we're sitting here, we don't feel it, but we're sitting here humming along at, whatever, 98.6 degrees Fahrenheit, significantly higher than room temperature. Cause, we're generating our actual biochemical process of life, right? Bioelectrical is generating heat and dumping it out. Anyway, so the idea of the superconductor is basically, think about it in the abstract as a wire that basically transmits information without, with basically perfect fidelity, perfect conservation of energy without dumping any heat into the environment. And it turns out that if you do that at room temperature, then all of a sudden you can have basically incredibly more efficient, kinds of batteries, electrical transmission, motors, computer chips. And so you can start to think about, for example, just an example people talk about is if you cover the Sahara Desert in solar panels, you could power basically the entire planet's power energy needs today. The problem is there's no way to transmit that transfer that power from the Sahara to the rest of the world. With existing transmission line technology. With superconducting transmission lines, all of a sudden you could. Quantum computers, today they exist, but they're sharply limited because they have to be operated at these, super cool temperatures, in these very carefully constructed labs. With superconductors, in theory, you have desktop quantum computers. You have levitating trains. You've got, you have a very broad cross section. You have handheld MRIs. Right, like every doctor, every nurse, has an MRI, and they can just take a scan wherever they need to, on the fly, in like the Star Trek, the tricorder, kind of thing. And so anyway, it's fascinating. So sitting here today, there's the reports of this breakthrough, and there are these sort of almost UFO style videos of this material levitating, where it's not supposed to be levitating as a consequence of this breakthrough. And there are betting markets on scientific progress, and the betting markets, as of this morning, have the odds of this being a real breakthrough at exactly 50-50.
Not the worst odds.
No, but it's funny if you think about it. It's funny because it's our entire world right now, from a physics standpoint, is like Schrodinger's cat. Like we live sitting here today in a superposition of two worlds, one in which we now have room temperature semiconductors and one of which we don't. And people are, and these are radically different potential futures for humanity, right? And so if it turns out it's true, it's an amazing step function breakthrough. If not, it'll set us back, and people will go back to trying to work on to figure it out. But but between the time we're recording, between the time we release, we may even find out whether the superconducting cat in the box is alive or dead.
That alive or dead state, I mean, these two separate futures is really something that I I see, when I was reading your blog, when I was looking at effective accelerationism, and in accelerationism we'll get to, but these two futures, I think, is the big question that I want to ask you, which is because you've lived through this time, which is going through the optimism of the 90s, especially, you mentioned Nick Land at the start. I mean, you see that in philosophy, you see that in technology, you see that in the history, this huge, so let's call it a cyberpunk optimism regarding our technological future. And I would say now, I don't know, whether or not you agree with me, please let me know. We have entered into what Land himself called a slump from the 2000s, like late 2000s, early 2000s onwards. And there seems to be within the air a sort of cynicism, a sort of pessimism that we've just ended up in this like place of stagnance. And do you see? I mean, if you agree with me in terms of those two possibilities, I think I would be right in saying you're an optimist. Do you see us now re-entering into that a new phase of optimism regarding technology and regarding the future?
Well, so there's several layers to this question, and I would be happy to kind of go through them. So we can spend as much time on this as you want. But the core layer when talking about, and I totally acknowledge and I think this is a great topic, and your observations are very real. The core thing that I would go to start with is not kind of the social, political, philosophical dimension. The core thing I would go to start with is the technological dimension. In other words, at the substantive level, like what is the actual rate of technological change in our world? And you'll note that on the social dimension, we seem to whip back and forth between, oh my God, there's too much change, and is she stabilizing everything? And then we whip right around to, oh my God, there's not enough change, and we're stagnant, right? And it's horrible. So there's kind of dystopian versions, there's kind of dystopian mindsets in the air, kind of in both directions. So anyway, I would start with kind of the technological kind of substantive layer to it. And there, the observation, and this is not an original observation on my part, Peter Thiel and Tyler Cohen in particular have gone through this in a lot of detail in their work. But, basically, like if you look at the long arc of technological development over the course of, which effectively started with the Enlightenment, right? So you sort of, practically speaking, you're sort of starting around 1700 and, projecting forward to today. So about 300 years worth of what we would consider kind of systematic technological development. It's basically, if you look at kind of that long arc, and then if you basically measure the pace of technological development, and I'll pause by saying you actually can measure the pace of technological development in the economy with a metric that economists call productivity growth. And basically the way that works is, economic productivity is defined basically as output per unit of input. Right. And you can, whatever your inputs are, it could be energy, right? It could be, raw materials, whatever you want. And then, output is in, actual output, more cars, more chips, more this, more that, more clothes, more food, more houses. And so basically what economists will tell you is the rate of productivity growth in the economy, which they measure annually, basically is the rate of technological change in the system. Right. And so if technology is paying off, right, if the advances are real, then your economy is able to generate more output with the same inputs. If your technological development is stagnant, then that's not the case. And it's an aggregate measure, but it's a good measure overall. If you look at those statistics, basically what you find is we think more recently in the last century, we had very rapid productivity growth in the West, basically for the first half of the 20th century. So from the basically, what was called the Second Industrial Revolution, which started around 1880, 1890, through to basically the mid 60s, we had actually a very rapid rate of technological development. And by the way, in that era, right, we got, the car, the interstate highway system, the power grid, telegraph, telephone, radio, television. We got computers, we got, we got like we got the, atomic, we got, both atomic weapons and also nuclear power technology. Right. And so there was this tremendous kind of technological surge that took place, in that sort of, call it 1880 to 1965 kind of period. And productivity growth ran, through that era, 2 to 4% a year, which in the aggregate is very fast, for the economy overall. Like that's a very fast pace of change. Basically, since the mid 60s, early 70s, the rate of productivity growth basically took a sharp deceleration. And so in the basically the 52 years now that I've been alive, it's been a step lower. It's been 1 or 2% a year. It's been kind of persistently too low. relative to what it should be. And I think there's a bunch of possible explanations for that. But I think the most obvious one is that basically the world of technology bifurcated in the 70s and 80s into two domains. One domain is the domain of bits, the domain of computers and the internet, where there has been, obviously very rapid technological development, potentially, now culminating in AI. But then there's also the world of atoms, and the diagnosis, at least that I would apply, is we essentially outlawed technological development and innovation in the realm of atoms, basically since the 1970s. There are many examples of how we've done this, and you can look at things like housing policy, and you can kind of see it quite clearly. But also, very specifically, you can see it in energy, which is we discovered nuclear power, right? We discovered a source of unlimited zero emissions energy that compared to every other form of energy is like ultra safe. Nuclear energy is like by far the safest form of energy that we know of. And in the 1970s, we essentially made it illegal. Just like totally banned it. And we talk more about that, but like that was like a draconian thing that has consequences through to the world we live in today. And so we live in this sort, and you mentioned cyberpunk, and this is actually kind of the cyberpunk ethos that I think actually reflects something real, which is, if you're in the virtual world, it's like, wow, right? It's like, it's amazing. Like everything is like spectacular. And look, even like a podcast like yours, like, right, would have been, inconceivable 30 years ago. Right. And so like information transmission, communication, coordination, all these things have taken huge leaps forward. But then the minute the minute you get into a car, or the minute you plug something into the wall, right, or the minute you eat food, right, you're still living in the 1950s. And so I think we live in a schizophrenic world with respect to that question.
Why then? So you write about this in your blog post on AI, which we'll get to, but you draw in Prometheus, right? This consistent historical cycle of when there is a new technology, it's going to destroy us, everything's going to end, it's the worst thing ever, we need to be careful of it. The TV is going to burn your eyeballs out of your sockets, the vacuum cleaner is going to, explode or whatever, but every time there is a cyclic change of a new technological innovation, it's this Promethean thing of we're pretty terrified of it and we want it to go away, and then eventually we're like, oh, actually no, that's pretty helpful. But there seems to be, as you said, there's something that happened in the 1970s where we just pushed away the atomic world in favor of the bits, which makes sense. But why? I mean, there's probably a lot of governmental reasons for this as well, but why were we so, it seems like a fear, really, the way you talk about it. Like, why were we so, in a way, scared to then develop the atomic world in the way we had the bit world?
Yeah, so I start even deeper, I think, which is there's a deep fear in the human psyche, and I think probably in the human animal, of new knowledge. Like it's even a level, like technology is an expression of knowledge, right? Like the Greeks had this term techne, which is sort of this, which is where the word technology comes from, but I think the underlying meaning is more like general knowledge. The Christian, the key to the Christian, kind of theology, right, is what is, what was the original sin, right? It was eating the apple from the tree of knowledge, right? It was mankind, right? Mankind learning that which he was not supposed to learn. And so, the Greeks had the Prometheus myth, the Christians have the snake in the Garden of Eden and the tree of knowledge. There's something very, very deep. There's an asymmetry, I think, wired deeply into the human brain, right? Which is, fear versus hope. Which from an evolutionary standpoint, would make a lot of sense, right? Which is okay, if you're living in, let's say, prehistoric times, in the sort of long evolutionary landscape that we lived in, is new information likely to be good or bad? Right. Probably over the sweep of, the billions of years of evolution that we went through, most new information was bad, right? Most new information was the predators coming over the hill to kill you. And so I think there's something deeply resonant about the idea that new is bad. And by the way, look, in the West, we probably, we actually, I think, from a historical and maybe comparative standpoint, we're actually quite enamored by new things as compared to a lot of traditional societies. And so if anything, we've overcome some of our natural instincts on this, but that impulse is still deep. And then if you go up one level to kind of the social level, I'm quite bought into an explanation on this that was provided. There was a philosopher of science, historian of science named Elton Morrison at MIT in the first half of the 20th century, who talked about this. And he said, look, you need to think about basically technology intersects with social systems. When a new technology intersects with a social system, basically what it does is it threatens to upend the social order. right? And so at any given moment in time, you have a social order, right, with status hierarchies, right, and people who are in charge of things. And basically what he says is the social order of any time is basically, in sort of Western, sort of modern, sort of Enlightenment Western civilization, the social order is a function of the technologies that led up to it. Right. And so you have a certain way of organizing the military, you have a certain way of organizing, industrial society, you have a certain way of organizing, political affairs. And they are the consequence of the technologies up to that point. And then you introduce a new technology, and the new technology basically threatens to upend that status hierarchy. And the people who are in power all of a sudden aren't, and there are new people in power. And of course, what is the thing that people will fight the hardest to maintain, is their status in the hierarchy. And then he goes through example after example of this throughout history, including this incredible example of the development of the first naval gun that adjusted for the role of a battleship in battle, which increased the firing accuracy of naval guns by like 10x. It was one of the great decisive breakthroughs in modern weaponry. And it still took both the US and the UK British navies 25 years to adopt it. Because the entire command status hierarchy of how naval combat vessels were run and how gunnery systems worked and how tactics and strategy worked for naval battles had to be upended with the invention of this new gun. Anyway, and so he would basically say, essentially, you roll out this new technology, it causes people who used to have power to no longer have power, puts new people in power. In modern terms, the language that we would use to describe this is gatekeepers, right? So, why is the traditional journalism press so, just absolutely furious about the internet, right? And it's because the internet gives regular people the opportunity to basically be on at least a peer relationship, if not, in the case of somebody like Joe Rogan, a superior relationship, right? And then it's an upending of the status hierarchy, and kind of the same thing through basically one of the ways to interpret the story of our time from a social standpoint is all of the gatekeepers who were strong in the 60s and 70s are basically being torn down. I'll give you another obvious example: political parties, right? Why are so many Western political parties in a state of some combination of freak out and meltdown right now? Right. It's because in an era of radio and television, they were able to broadcast a top-down message, and they were able to tell voters basically what to think. In the new model, voters are deciding what they think based on what they read online, and then they're reflecting that back up and finding their politicians wanting. Right. And so therefore, the re-rise of populism and sort of the blowing out of sort of both left-wing and right-wing ideologies. Right. The center is not holding. And so anyway, that would be another example in Morrison's framework. And then I'll just close on this. Morrison has this fascinating. He says there's this, as a consequence of the fact that technology changes social hierarchies. He says there's a predictable 3-stage process to the reaction to any new technology by the status quo, by basically the people in power at that time. He says step 1 is ignore. And so just pretend it doesn't exist, which by the way is actually a pretty good strategy, because most technologies don't upend social orders. Most new technologies don't work at the time that they're first presented. Mm-hmm. So maybe ignore is actually a rational strategy. Step 2 is what he calls rational counter argument. And so that's where you get the laundry list of all the things that are wrong with the new technology. Right. And then he says step 3 is when the name calling begins.
Mm-hmm, mm-hmm. This, I've watched a couple of your other interviews recently, and this relates to, I know you've been talking about Nietzsche's master and slavery morality recently, and this seems to tie to that in this notion of Nietzschean result. He does the typical philosophical thing of taking a French word and drawing it out, but ressentiment, right? Instead of just having a look at nuclear power and seeing where it would go and allowing that power to unfold within society, you try invert the morals. So you say, well, actually the good thing to do is, because these people don't have the will to power, because they don't have the ability or the engineering skills, I guess in your own case, to utilize the thing, they invert the morals and say, well, actually the good thing is to do the inverse, is to not have it. This is bad, and now that then immediately puts them in the good camp. But it seems like, to be honest, it really feels, especially with AI and also now with nuclear power, now that, especially in Germany, certain things have been tried, and now it's okay, this was a really bad mistake in terms of energy. The cat's out of the bag, and there's now this force of having to move. You were then talking about the second and third stages there. It's almost look, with AI especially, the cat's out of the bag. We have to move. There's no choice of ignoring or reacting against it now. You either deal with it or you don't.
Yeah, so let's spend a little one more moment on nuclear power, and then go to AI. So nuclear power is so interesting because nuclear power is the tell. Like I always look for like the little signals that people don't really mean what they say, or that they're not really like their sort of moral system doesn't quite line up properly. And so nuclear power is this like amazing. It's this amazing thing. It's like literally, it's like, okay, you build this thing, it generates power. It basically generates a small amount of nuclear waste. It generates steam, but it generates zero emissions, right? Zero carbon, right? And so you have this basically this amazing phenomenon where you have this, and let's just take them completely as face value. I'm not going to, this is not me questioning. I'm not going to question carbon emissions or global warming. I'm going to assume that everything the environmentalists say about carbon emissions, climate, change, all that stuff. Let's assume that that's all totally real. Like, let's just grant them all that. It's like, okay, well, like, okay, so how can you solve the sort of climate crisis, the carbon emissions crisis? It's like, well, you have the silver bullet technology you could roll out in the form of nuclear fission today. You could generate a limited power. Richard Nixon, by the way, the heavily condemned Richard Nixon in 1972, proposed something at the time he called Project Independence. Project Independence was going to be the United States building 1,000 new civilian nuclear power plants by the year 1980 and cutting the entire U.S. energy grid, including the transportation system, cars, everything, home heating, everything over to nuclear power by 1980, going zero emission in the U.S. economy. And by the way, right, geopolitically removing us from the Middle East, right? Right. So no Iraq, Afghanistan, all this stuff, like just completely unnecessary, right? And you'll note that like Project Independence did not did not happen, right? Like we don't live in that world today. And so it's like, okay, you've got this like crisis, you've got this like silver bullet solution for it, and you very deliberately have chosen to not adopt that solution. And it's like, and there's this actually very interesting split in the environmental movement today, and it's really kind of I think kind of bizarre. And it's like a 99-1 split. If you ask like 99% of environmental activists about nuclear power, they just sort of categorically dismiss it. Well, of course, that's not an option. You do have this kind of radical fringe with people like Stuart Brand, who are like basically now pointing out that it is the silver bullet answer. But most of them are saying, no, it's not an answer. And it's like, okay, well, why are they doing that? It's like, well, like what is it that they're saying that they want to do? And what they're saying they want to do is what they call, degrowth, right? And so they want to decarbonize the economy. They want to de-energize the economy. They want to degrow the economy. And then, when you get down to it and you ask them a very, specific question about the implications of this, basically what you find is the general model is they want to reduce the human population on the planet to about 500 million people. It's kind of the answer that they ultimately come down to. And so ultimately the big agenda is to reduce the human, basically the human herd, quite sharply. And they kind of dance around this a little bit, but when they really get down to it, this is what they talk about. And of course, Paul Ehrlich, is kind of one of the kind of famous icons of this. He's been talking about this for decades. I think it was Jane Goodall who used the 500 million number recently in public. And so then you got this kind of very interesting, technological, philosophical, moral question, which is like, well, what is the goal here, right? Is the goal to like solve climate change, or is the goal to like depopulate the planet, right? And to the extent that like free unlimited power, right, would interfere with, to the extent that that's a problem, the problem it would be is if the actual agenda is to depopulate the planet. And like I would like this to not be the case. Like I think again, taking everything else that they say at face value, you'd like to solve carbon emissions and climate change and everything else, but like I think you might also say you want a planet in which there are not only 8 billion people, but maybe people are good, right? And maybe you actually should have 20 billion or 50 billion people. And we have the technology to do that, and we're choosing not to do it. So this is the thing. Like this gets into these very deep questions, right? To your point of like, okay, very deep questions about morality and like how did we maneuver, or like per Nietzsche, like how did we reverse ourselves into a situation where we're actually arguing against human life? And of course, and this is, we'll get to it, but this of course is then a big part of the origin of the idea of effective accelerationism, which is basically new. Like let's go sharply in the other direction. And then AI, AI is playing out much the same way. AI is already playing out the same way, and here you've got this like just incredible phenomenon happening where we it looks like we have a key breakthrough to basically increase the level of intelligence, basically all throughout society and around the world, through for the first time, directly applying new general intelligence to the world. And there is this like incredibly basically aggressive movement that is actually having tangible impact today in the halls of power in Washington, D.C. and in the EU and other places, that is seeking to stop and reverse it, as aggressively as they possibly can. And so we're going through, I would say, a suddenly accelerated and very sharp and aggressive version of exactly what happened with nuclear power happening with AI right now.
Mm-hmm. I mean, this is the thing that well, there's two questions, because on your blog, it's really refreshing to see you're pretty to the point when you say, look, AI is code. It's code written by people, by human beings, on computers, developed by human beings. Like, we're in control. You're not of this. I think there was, Musk signed a big thing where, 1,000 people signed this thing to say, we need to halt this. The whole Rocco's basilisk, AI is going to be Terminator 2, coming and blowing us up with robots, etc., etc. It's going to kill us all. You're very much like, no, this is code. This is just an intelligence for us to use. Now, that's one question, I guess. Why isn't AI going to kill us all? And I know you've spoken about that a lot, so that answer can be brief. But secondly, this whole idea of trying to reverse it, to me, it seems inherent within AI as a thing that once, it's the cat's out of the bag, you can't. Once it's here, you outside of really draconian measures, you can't, because how do you halt an intelligence which is growing, right?
Well, except, they did stall out nuclear power, right? So, right. So they did, it worked. So why did Project Independence not happen? Why do we not have unlimited nuclear power today? The reason is because it was blocked by the political system. Right. And so Richard Nixon, who I mentioned, proposed this. He also created the Environmental Protection Agency and the Nuclear Regulatory Commission. The nuclear, this actually been a big week. The first new nuclear power plant the first newly designed nuclear power plant in the last 50 years just went online in Georgia. We're at $20 billion over budget, and it's a story of its own. But at least we got one online. It's the first new nuclear power plant design ever authorized by the Nuclear Regulatory Commission since Nixon created that commission, right? And so we put in place a regulatory regime around nuclear power in the 1970s that all but made it impossible. By the way, you alluded to the Germany thing earlier. I'll just touch on that for a second. So. I'm sure you've heard of the idea of the precautionary principle, right? Right, which is this idea that basically scientists and technologists have a moral obligation to think through all the possible negative consequences of a new technology before it's rolled out. The precautionary principle, and we could talk about that, including whether scientists and technologists are actually qualified to do that. But this was also a central theme of Oppenheimer. But the precautionary principle was invented by the German Greens in the 1970s, and it was prevented specifically to stop nuclear power. It is just amazing. We're sitting here in 2023, and there's this, we in the West are effectively at this, at war with Russia. Right. It's a proxy war right now that, hopefully doesn't turn into a real war, but who knows? The proxy wars have a disconcerting, pattern of spilling over into becoming real wars. A lot of this it's a tale of energy. Basically the Russian economy, is like 70% energy exports, right? Oil and gas exports. The major buyer of that energy historically has been Europe, and specifically Germany. Europe and Germany specifically essentially have funded the Russian state, the Putin state, and that funding is what basically built and sustains their military engine, which is what they've used to invade Ukraine. Right. And so it's this there's this counterfactual, right, where the German Greens did not do what they did in the 1970s. Nuclear power was not blocked. Germany and France and the rest of Europe today is fully energy independent, running on nuclear power. The Russia state, it would be greatly weakened because the value of their exports would be, enormously diminished. And they would not have the wherewithal to invade other countries or to threaten Europe. And so these decisions have real consequences. These people, I'll use the pejorative sense, they are so confident that they can step into these, debates, kind of questions around, new technologies and how they should be applied and what the consequences are. They can step in and they can use the political machine to basically throw sand in the gears and stop these things from happening. So AI, this is what's happening to AI right now. So in the sort of, theoretical position where AI is kind of this, potentially runaway thing, then, right, maybe it can be constrained. In the real world, it very much can be constrained. And the reason it can be constrained in the real world is because it uses physical resources, right? It has a physical layer to it. And that layer is energy usage, And that layer is chips, and that layer is, telecom bandwidth, and that layer is data centers, physical data centers, right? And that layer is like, and by the way, that layer also includes the actual technologists like working in the field and their ability to actually do what they do. And there are, a very large number of sort of control points and pressure points that, the state can put on those layers to prevent them from being used for whatever it wants to prevent. And look, the EU is on the verge. The EU has this like anti-AI bill that it looks like is going to pass that is like extremely draconian and may result in Europe not even having an AI industry, and may result in, American AI companies not even operating in Europe. And then in the US, we have a very kind of similar push happening as, the sort of what I would describe as the anti-AI zealots, they are in the White House today, right? Arguing that, this is bad, it should be stopped. And it's like, it's amazing because it's like on the one, like how many times are we going to like run through this loop? How many times are we going to like repeat history here? How many times are we going to be kind of self-defeating like this? And like apparently the impulse to be self-defeating, we have not worked it out of our system.
You don't want to be self-defeating though. I mean, let's move into this peculiar 4 letters, which is found at the moment at the end of your Twitter name, and the end floating around Twitter mostly E/AC or effective accelerationism. And this is just beautiful to me. It's like the accelerationist renaissance. I've been talking about it in that way. I don't want to gatekeep it too much, but I wrote my master's thesis on accelerationism. Like I love it. I love talking about it. You don't want any of this holding back. You don't want to hold anything back. You want to accelerate. So firstly, I mean, there's 2 questions there. What is it for you to accelerate, and what is effective accelerationism?
Yeah, so let me just say where it came from. I'll answer the second one first, and then go to the broader topic. So it's a combination. There's kind of two words there: effective and accelerationism. So the accelerationism part of it is obviously building on what you've talked about and what Nick Land and others have talked about for a long time. And of course, as you've talked about, there's all these different versions of accelerationism. And so this is proposing one that, this one is like the closest to what you would call right accelerationism, although, maybe without some of the political overtones. And so there is that component. There's also the effective part of it. And the effective part of it, it's sort of a half humorous reference, obviously, to effective altruism. And it's a little bit tongue in cheek because it's like, of course, if you're going to have a philosophy, of course, you would like it to be effective. But but also look, like EAC is like very much like EAC's enemy, right? The oppositional force or the thing that EAC was sort of formed to fight is actually, specifically effective altruism. Right. And so it's also like you also sort of use that term to the term effective to kind of make that point, like this is in that world and this is opposed to that. And the reason why like this is happening now, like the reason why the concept of effective accelerationism, has kind of come into being. And by the way, the people, this is not originally my formulation. There's these kind of ultra smart Twitter characters, who I think are still mostly operating under assumed names. But there's Beth Jesus and Bazlord are the two of them that I know. And they're, these are like top end Silicon Valley, engineers, scientists, technologists. But at least for now, they're operating kind of undercover pseudonym. So the reason this is happening now is because of what I was describing earlier with AI, which is you have this other movement. You have this movement of what's sort of called, sometimes use different terms: AI risk, AI safety, AI alignment. Sometimes you'll hear the term X risk. Sometime, and then this is sort of directly attached. This is all part of the, EA world, the effective altruism world. And then, the central characters of this other world are, Nick Bostrom, Eliezer Yudkowsky, the Open Philanthropy Organization, a bunch of these kind of, it's sort of the AI, what we call the AI doomers. Running around, like the AI doomer movement is basically part and parcel with the effective altruism movement. AI existential risk has always been kind of the boogeyman of effective altruism, kind of going back, over the 20-year development of EA. And so anyway, that EA movement is the movement, by the way, with lavish funding by like EA billionaires, which is part of the problem, by the way, who made all their money in tech. which is also amazing. But so you've got this funding complex, you've got this EA movement, you've got this attached AI risk safety movement, and now you've got like active lobbying, and a sort of anti-AI PR campaign. And so anyway, so effective accelerationism is intended to be the polar opposite of that. It's intended to be the to head boldly and firmly and strongly and confidently into the future. It's like why this form of positive accelerationism? There's a couple different layers of it. The founders of the concept of EAC have a thermodynamic kind of thing, which we could talk about, but it's kind of one layer down from where I operate. The layer I operate is more at the level of engineering, and when I think about it, I think in terms of essentially fundamentally of material conditions. So human flourishing, quality of life, standard of living of human beings on Earth, and back to that concept of productivity growth. The application of technology to be able to cause the economy to be more productive, and therefore cause more material wealth, higher levels of material welfare, for people all over the world. By the way, also with reduced inputs. Right. Mm-hmm. And so not just greater levels of development and greater levels of advance, but also greater levels of efficiency. And the nature of technology as a lever on the physical world is you can't have your cake and eat it too. You can get higher levels of output with lower levels of input. And the result of that is a much higher standard of living. So I kind of adopt my philosophical grounding is sort of, I don't know if I call it like a positive materialism or something, which is like, I think the thing that the technology industry does best is improve material quality of life. Mm-hmm. I think that we should accelerate as hard into that as we possibly can. I think the quote unquote risks around that are greatly exaggerated, if not false. I think the forces against basically technological progress, they're like the environmental movement I described. They're fundamentally, sort of at some deep level, they're sort of anti-human. Mm-hmm. They want fewer people and they want a lower quality of living on Earth. And I very much disagree with both of those.
Mm-hmm. And what is this at the thermodynamic level? Is this the, our ultimate enemy is entropy?
So the thermodynamic part gets complicated, and this is not my field. So there's other people that you should probably have on to talk about this. But the effective accelerationism version of the thermodynamic thing is based on the work of this physicist named Jeremy England, who is this very interesting character. He's actually trained by one of my partners, and is now basically. He's an MIT, physicist, biologist, and by the way, interesting guy. I don't know him, but a very interesting guy from a distance. He's also a trained rabbi, and so he's an interesting cat. And so he basically has this theory that basically it's sort of life is the direct result. Life, like the phenomenon of life itself is a direct consequence of thermodynamics. And the way he describes it is basically if you take basically the universe with the level of energy that's washing around and raw materials, and you sort of apply kind of natural selection at a very deep level, even at the level of just like the formation of materials like on a planet or something. You basically have this thing where basically matter wants to organize itself into states where it's able to absorb energy and achieve higher levels of structure. And so you have absorption of energy, you have achievement of higher levels of structure. In the case of organic life, that's starts with basically RNA and then kind of works its way up to full living systems. And then on the other side of that, as we talked about before, on the other side of that is the result of that is you're dumping heat, which is to say entropy, kind of out into the broader system. And so it's almost like saying the second law of thermodynamics has an upside, right? Which is basically, yes, entropy in the universe is increasing over time, but a lot of that increase is the result of structures forming that are basically absorbing energy and then exporting entropy. And one form of that structure is actually life. And this is actually a thermodynamic, biomechanical, bioelectrical kind of explanation of actually how organic life works. Like this is what we are. We are machines for gathering energy, forming increasingly, complicated biological machines, replicating those machines, right? And of course, he talks about natural selection. Like it's not surprising that natural selection is so oriented around replication, right? Because replication is the easiest way to generate more structure, mm-hmm. right? Like replication is the way that a system that is basically in business to generate structure. It's the way that it can most efficiently generate more structure. So anyway, basically the universe wants us to basically be alive. The universe wants us to become more sophisticated. The universe wants us to replicate. The universe feeds us an essentially a limited amount of energy and raw materials with which to do that. Yes, we dump entropy out the other side, but we get structure and life, to basically compensate for that.
The universe is pronatalist and kind of Nietzschean there as well.
Yeah, exactly, 100%. Yeah. So anyway, that's the thermodynamic. That's the thermodynamic underpins of effective accelerationism. The people who have encountered effective accelerationism, some of them get very deeply into that, and there's a very deep kind of well there to draw from. This guy Jeremy England has a book out. Actually, you'll appreciate this. This guy Jeremy England has a book out, and the title of the book is something like "Every Life is on Fire." And it's actually funny because it's like if you read Heraclitus, you're like, oh my god, he saw it. Right, like it's like there's something very, very deep going on here with this sort of intersection of energy and life. So he's got this book out, which apparently is quite good. And so some people in effective acceleration kind of go deep. There's a tongue-in-cheek reference to the so-called thermodynamic God, right? Which is not a literal, religious in the literal religious sense, like a sort of a conscious God or a sentient God, but more this idea that the universe is sort of designed to express itself in the forms, basically in higher and higher forms of life. To your point, like there's an obviously direct Nietzschean connection. So maybe he saw a lot of this too. And obviously he was obviously writing and thinking at the same time Darwin was figuring a lot of this out on the natural selection evolution side. So there's that. But having said that, like I said, my take on it is more, I find that stuff fascinating. I'm more naturally inclined as an engineer, more naturally inclined towards the material side. And so I just more naturally think in terms of the social systems and the technological development and the impact on material quality of life. And so I think you can also just take it at that level and not have to get all the way down into thermodynamics if you don't want to.
Mm-hmm. Drawing it down to this level of engineering, well, not down to, but just to this level of engineering, there's this odd learned helplessness. And just to take the two examples we've given so far, so, they work quite well, actually, nuclear energy on the atomic side and AI on the bit side of things, virtual reality and reality. You posted this really interesting essay on your blog about availability cascades, which is about basically, in short, if I'm getting this right, this idea of why are so many people interested in this thing or this view of whatever the opinion or the idea is that's floating around. And it seems on both of those, both nuclear energy and AI, we have that same opinion, which is like mimetically infected culture of a sort of learned helplessness. Like, oh no, we've already spoken about this a bit, but like, oh no, we need to get rid of this. We can't deal with this. But it seems, do you think on the engineering side of things, and I guess it overlaps also into the social in terms of how you engineer and how you promote these ideas socially as tools, as things that people use, is an attempt to like invert that availability cascade and like try to like begin some mimesis on the side of like, it's okay to want a better quality of living. It's okay to want to grow. It's okay to want energy. Like you don't have to be almost like submissive to whatever this strange self-defeating learned helplessness is that we have in terms of technology and our weird allegiance to just this stagnant comfort that we've had for too long.
Yeah, that's right. That's exactly right. And like I said, like we talked about earlier, like there's this. I think there's a natural human impulse deeply wired into like the limbic system or something, which is basically fear over hope, right? Like what's most likely to come over the ridge, right? A saber-toothed tiger to eat you, or like something warm and cuddly that wants to be your friend, right? I guess a quokka or something like that, right? So. Right, it's probably the tiger, right? And there's a sort of false positive, false negative, right? Two ways of making mistakes, and you definitely, from an evolutionary standpoint, want to err in the direction of being more. You want to overestimate the rate of saber-toothed tigers, right? To survive. So that impulse is deep, yeah. But then what we have is we have sentience. We have we're not just limbic systems anymore. We have the ability to control our environment. We have the ability to build tools. We're not afraid of saber-toothed tigers anymore. We have the ability to shape our world. We developed rationality and the Enlightenment and science and technology and markets and everything else to be able to control the world, to our benefit. And so we don't have to live cowering in fear anymore. As much as that might be like grimly satisfying, like we don't actually have to do that. And there's actually there are many good reasons over the last 300 years to believe that there's a much better way to live. But look, somebody has to actually say that. And then look, I think the other part is, I think there's a big divide. I think there's a big divide between. I'll pull out my Burnham on this a little bit. Is a big divide on this stuff between what you describe as the elites and the masses. That has turned out to be pretty interesting. So the I would say this problem of fear of technology, or hatred of technology or desire to stop technology, I think it's primarily a phenomenon of the elites. I actually don't think it's particularly shared by the masses. It just seems like, I'll just take AI as an obvious example. One of the amazing things about AI is it's like freely available for use by everybody in the world right now today, fully state of the art. Like the best AI in the world is on websites from OpenAI and Google and Microsoft, and you can go on there and you can use it for free today. And people, 200 million people, something like that around the world are already doing this, right? And if you talk to anybody who's, if you talk to any teacher, right, they'll already tell you they've got students using ChatGPT to write essays and so forth, right? And so you've got this amazing thing where, like the internet before it, and like the personal computer before it, and like the smartphone before it, AI it's like immediately democratized, right? Like it's immediately available in its full state of the art version. Like there's no more advanced version of like GPT that I can buy for $1 million than you can get for free or by paying $20 for the upgraded version on the OpenAI website. Like the state of the art stuff is fully available for free. And so you have people all over the world, and this would be a source of optimism that the AI doomers are going to lose almost by definition, right? Is you have people all over the world who are just already using this and they're getting, great value out of it in their daily lives. They love it. They're having a huge amount of fun with it. It's great. They're, making new art and they're, doing all kinds of, asking all kinds of things, and it's helping them in their jobs and in school and everything else. And they love it. So I think there's this thing where, like, I actually think that what we're actually talking about from a social standpoint is basically essentially a corrupt elite, right? A corrupt oligarchic elite that basically has been in a position of gatekeeping power, for basically in its modern form for 60 years. And every new technology development that comes along is a threat to that. And back to the Morrison thing, like that's why they hate and fear new technology. They would very much like to control it. It's like social media, like they're all just like completely furious about social media, but 3 billion people use social media every day and they love it. And so it's only the elites that are constantly kind of raging against it. The problem is the elites are actually in charge, right? From a formal, government, like they actually have the ability to write laws. By the way, you also see this in polls. If you poll on, there's two very interesting kind of phenomena kind of unfolding if you do these broad-based polls on trust in institutions. And there's organizations, Gallup in particular, and then there's another organization called Edelman that does these polls every year of basically, essentially they poll regular people, and the question is like, which institutions do you trust? And institutions here includes everything from the military to religion to schools to government to journalism to big companies, big tech, and so forth, small business. And basically the two big themes you see in those polls is one is ordinary people trust in institutions, trust in any sort of centralized gatekeeping function, has been in basically secular decline basically since the 1970s, corresponding to the period we've been talking about. And so generally people as a whole have kind of had it with the gatekeepers. Which is very interesting. And by the way, that phenomenon, actually, the beginning of that predates the internet and social media, and so that traces back to the early 70s. And so I think that, which I think is not an accident, because it's where the current regime basically essentially took control. And then the other thing that's so striking is that although you can sit and read the news all day long, and where they just like hate on tech companies all day long, if you do the poll of basically businesses by category, tech polls by far at the top. And so again, ordinary people are just like, wow, my iPhone's pretty cool, I kind of like it. And this ChatGPT thing seems really nifty. And so I do think there's this weird. Like, I do think there is this aspect of this where are like, it's a cliche to say the elites are out of touch. Of course, the elites are out of touch. The elites are always out of touch. But like, it seems like the elites are particularly out of touch right now, including on this issue. And another way kind of through this knothole is, they may just simply discredit themselves. Like the EU is a great example. The EU may pass this anti-AI law, and the population of Europe might just be like, "What the hell?"
Mm-hmm.
Right? And so that would be another white pill against what otherwise looks like a deep kind of drive in our society for stagnation.
It would also be really strange to try and find a way to like define AI in that sense, because it's not like we haven't been using it in a minor form before all this for a while, right? So I don't know how they'd go about defining that in that way.
Yes. So do you ban linear algebra? Right? Do you ban linear algebra? And it's actually really funny because I don't know if you know this, there actually is a push underway to quote unquote ban algebra, and it's literally in California. There's a big push underway to drive it out of the schools in California. So there's a big push. First, it started with a push to drive calculus out of the schools in California, and now it's extended to drive algebra out. And of course, this is being done under the so-called rubric of equity, right? Because it turns out, test scores for advanced math, vary by, vary by group. And so, there's this weird thing where, like in California, we're trying to push algebra out of the school. In Washington, we're trying to push algebra like out of tech. Like the whole thing is, and this is where I get like really, this is where I start to get emotional, because it's like, really, like we spent 500 years climbing our way out of primitivism and getting to the point where we have like advanced science and math, and we're literally going to try to ban it. I was involved. If you remember this, there was actually a similar push like this. There was a push in the 1990s to ban cryptography, right? To ban the idea of codes. Right, ciphers, right? And as you probably know, like codes and ciphers are just math. Like all they are is math, right? And there was a move in the 1990s where people who thought that cryptography, obviously, there's all these anti-cryptography arguments because like bad guys can use it to hide and so forth. And so there was this like concerted effort by the U.S. government and other Western governments to ban cryptography in the 90s, and it took us years to fight and defeat that. And I was like, okay, that was so stupid. That will certainly never happen again. And like we're literally back at trying to ban math again.
Well, that does lead me just to the final question here, which is to do with the future. I mean, whether or not it's you're optimistic, pessimistic in relation to, I guess it would draw in on what we've just been talking about there. How do you envision the short-term future, which I've put down here like 10 to 50 years, and then what do you foresee for the year 3000 AD? Oh
boy. So I should start by saying I'm not a utopian. So, we talked a little bit earlier about kind of these impulses that kind of drive people to these kind of extreme points of view. Like the way I think about it is like there's a natural drive. A lot of people have what Thomas Sowell called the unconstrained vision. So they've got these kind of very broad-based kind of visions, and those visions kind of then split into like a utopian vision. And that might be, for AI, that might be something like the singularity, right? Or in the 1990s, these were called the extropians, right? Which is sort of this idea of kind of a material utopia as a consequence of like AI and let's say nanotechnology, on the one hand. And that's where, by the way, the idea of the singularity came from, right? Which is Ray Kurzweil and Werner Vinge. They were like, at some point, you get this kind of, point of no return, which is like a utopian point of no return. But then, of course, the flip side of every utopia is, apocalypse. And so then that's where the sort of AI, sort of the singularitarians 20 years ago have become a lot of them have become the AI doomers of today. And they have this sort of, they have the same utopian impulse. They've just flipped the bit and made it negative. So I should say, like, I'm not one of those. I'm probably more of a materialist and a little bit more of a, like I said, an engineer where, things, for example, have constraints in the real world. So I don't think we tend to get quite the extreme outcomes, but I do think we get change. Like we get change in the margin, and then change in the margin that compounds over time can become quite striking. So look, over 10 to 50 years, look, sitting here today, like if we want it, you can imagine the next 50 years to be characterized by the rise of AI. Looks like we kind of have figured that out now. This superconductor thing, if it's real, that's a, turning point moment. And by the way, if it's not real, it may be, that this result points us in the direction of something that becomes real in the next few years. And so you can imagine some combination of AI, superconductors, biotech, all these new techniques for, biooptimization, gene editing, and then, nuclear, if we get our act together on nuclear fission. By the way, there's a lot of really smart people working on nuclear fusion right now. Fusion is, would be an even bigger, kind of opportunity for unlimited clean energy. Now, the cynic in me would say if fission is illegal, then they're certainly going to make fusion illegal. But that's a choice. We all get to decide whether we want to live in a world where fusion is illegal. So we get nuclear fusion, and so sitting here 50 years from now, we basically are like, wow, we are like, we have, we are all much smarter than we were because we have these smart machines working with us and everything. We have solved whatever environmental problems we thought we had. We have abundant energy in an increasingly clean environment. We're curing diseases at a rapid pace. And new babies are born that are immune to disease. And so, not quite a material utopia, but like, a significant, meaningful step function upgrades in human quality of life. Like, I think that's all very over a 50-year period for sure. Like that's all very possible. Over whatever the year 3000, over a 1,000-year period. I mean, look, you do get into these questions, you do, if you're going to talk about 1,000 years, like you do get into these questions of like, for example, merger of man and machine, right? So you do have to, over that time frame, you have to start thinking about things like, the Neuralink, like where Neuralink takes you. And, you over that period of time, you'll definitely have like, neural augmentation. So, do you have shifting definitions of humanity? Where is the transhumanist movement actually taking us? Becomes a very interesting question over that time frame. Obviously, you have lots of questions over that time frame of space, exploration, getting to other planets, other life, either other life in the universe or not other life in the universe. So kind of the spread of the spread of our civilization more broadly. So there you truly get into science fiction scenarios. That's always fun to talk about. I will admit I am much more focused on the next 50 years.
I mean, is there anything you'd like to add into the conversation that you feel is key that we haven't touched upon?
Yeah, no, I think that was a good, it covered a lot of ground. So for effective accelerationism, just if you Google, there's a number of good already websites and Substacks talking about that. A lot of the conversations happening on Twitter. And I already dropped the names of the EAC guys. Beth Jesus and Baze Lord, definitely follow those guys. I've not met Nick Land, but I would definitely give a shout out and say for anybody who hasn't encountered his work, they should definitely read up on it. He is, I think, pretty clearly like the philosopher of our time, and not even because whether I agree or disagree with him on everything he said, and of course he's changed his views on a lot of things over time, but just the framework that he operates, like his willingness to actually go deep and actually think through the consequences of the kinds of technologies that I deal with every day, are just, I think, way beyond most other people in his field. And so it's, and I know he took kind of a long road to get here, so it's fun to see, it's fascinating to read that. I'll point to one other thing. So I already mentioned the Jeremy England book, and I'll point to one other book that people might find interesting. So a lot of Land's work and a lot of accelerationism, right, is based on the ideas of this field called cybernetics, which is kind of cybernetics is interesting because it's kind of this lost field of engineering. It was super hot as an engineering field from the 1940s to the 1960s. And it basically was sort of the original computer science. And then it was also sort of the original artificial intelligence. A lot of the AI people of that era kind of called themselves cybernetics or cyberneticists. But it really is an engineering field that kind of went away or got a lot more sedate after the 60s. But as I mentioned, like a lot of the ideas around AI and, world of machines and thermodynamics, a lot of those ideas were being explored as far back as the 30s and 40s. So the cybernetics people of that era thought a lot about a lot of these questions. Anyway, there's this great book. There's a lot of original source material on this. And the key character of that movement was Norbert Wiener, and there's a bunch of books by him and about him. But there's also a great book came out recently called Rise of the Machines by an author named Thomas Ridd, and it sort of reconstructs the archaeology of cybernetics and sort of makes clear how relevant those ideas are today. And so if you read that in conjunction with Nick Land's work, I think you'll find it pretty interesting.
I'll be sure to put the link for your Twitter and your blog in the description below as well. But yeah, I think that's a good place to finish up. Marc Andreessen, thanks very much.
Good, James, a pleasure. Thank you.